Yeah. Yeah. Hope any one of you, is it possible to just say what we have discussed in the last class? Yes, quickly, any one of you can say what I discussed.
We started with the recap of evolution.
Yeah.
Sir.
Yeah.
And then after that, we discussed about OFDM, sir.
OFDM. Okay. So I started with what are the key requirements of LTE design, right? I said the first thing is its performance should be on par with the wide broadband. Okay. So to achieve that, I said there are two network performance parameters, like one is high throughput and another one is ultra low latency. Right? That a high throughput means for this LTE design, the targeted peak throughput will be of how much I said. For downlink, it is of 100 Mbps when the spectrum is of 20 megahertz, and for the uplink, it is of 50 Mbps for the 20 megahertz spectrum. And it has the flexible or scalable bandwidth. What I can say means it can be operated in with a bandwidth of 1.4 megahertz, 3 megahertz, 5 megahertz, 10, 15, and 20 megahertz. And as far as the latency is concerned, it has been targeted to provide a latency of less than 10 milliseconds. Okay. So these are the few things. And then I said about the mobility. Okay. So then I told about the coexistence and interworking with the lower versions of the network. And it supports both FDD and TDD modes. Okay, so to begin with, okay, this is a summary. Just again, I wanted to highlight this LTE, that is 4G network, right? It will be operated in what? 900 megahertz band, 1800 megahertz band, 700 megahertz band, and 2.6 gigahertz bands. I said it supports variety of channel bandwidths. Again, I don't want to repeat that. And the last but not the least, that is the what? Reducing cost per megabyte. So that is the requirement. Okay. So that is reducing cost per megabyte with respect to what? High capacity, high spectral efficiency air interface by having flat architecture with a few number of network components and protocols. And it should have a single IP packet core for both voice and as well as data. And it should support self-configuration and self-optimizing network and technologies to reduce the installation and management cost. So keeping these things in mind, they have started with the key enabling technologies. Okay, so any one of you, is it possible to just mention what are the key enabling technologies to achieve these performances and service parameters which has been targeted for LTE? So they have come out with the key enabling radio technologies. What are those technologies? Radio and core network technologies. I said 5 things. Yes, I expect answer. At least name. Just name of those 5 technologies.
So carrier aggregation.
Pardon? Yes? Yes, what are the key enabling technologies? Just I mentioned, no, I put it in one slide. So these are the 5 key enabling technologies. Then I started with first one. Just I am asking you to mention the names of those 5 key technologies. Yes, Abhilash, can you just say what are those 5 key enabling technologies?
OFDM,
Yeah, first one is OFDM. Can you just expand what it is?
orthogonal
Just
frequency
expansion of
division
OFDM.
multiplexing.
Okay,
Oh,
orthogonal frequency division
is-
multiplexing. Fine. Then,
I think that's FDE and FDMA.
yeah, SC-FDE and
FDE,
SC-FDMA. That is a single carrier frequency domain equalization. Then single
and
carrier frequency domain multiple access. Yeah.
multiple access.
The next one. Yes, third one.
Some multi-antenna techniques.
Yeah, multi-antenna techniques. There is a fourth one. Third one you are missing, I think. Not able to say what it is. So it is channel dependent, multi-user resource scheduling. Yeah. Then the fifth one is IP flat, IP based flat network architecture. So these are the 5 key enabling technologies which have come out to meet the performance requirements of the LTE. Okay, so these things should be there in your mind at any time. You should be able to say with confidence, yes, these are the 5 key enabling technologies for the LTE. So we will be discussing about these things only throughout the semester. Okay, about each one of them we will be discussing. Okay, so I started with OFDM. Any one of you, is it possible to say what it is? Yesterday I briefed what it is and then I started with the advantages of that. Yes, quickly, I don't want to mention the names. I think people should communicate on their, what I can say, individual spirit. Otherwise, I think you are not listening. You are somewhere else. If you are with me, if you are able to grasp what I am saying, if you are able to understand, then obviously you will be able to say what it is, what I thought in the previous class. Yes, quickly, I spent almost 1 hour on that OFDM and I could say only 2 advantages of OFDM. Yes, see, only after mentioning name, if you are responding, that is not correct. I am giving freedom to all the students. They can open up their mouth and they can share their understanding. So some amount of two-way communication is required to proceed further. Otherwise, it will be just one way. I will be keep talking about the concepts. You will be either listening or not listening. How do I understand? Only if I get some positive response, then only. No? Otherwise, there is no point in being like this. Yes, let us not waste time for this only. Asking questions, getting response, unmuting and talking to me only, you're taking so much of time. Do you think that we have so much of time? You know, what is your last working day, right? It is not hardly 2 months. July something is your last working day. Immediately within 2 days, your exams will start. If you are at this speed, I don't think you will be able to pick up with this one. Okay. Because it is one of the core subject which you need to understand many things. It is not like just like a breakfast or lunch. You will not get that much of ready-made food what what I mean to say. You have to explore, you have to give time for this to understand, because it requires the basics of many things. Yes, quickly, come on, open up your mouth now. Why? If nobody responds, then I will not have any motivation to continue. I'm very sorry to say this, sir. So it shows what? Nothing has been taken away from that lecture, that's all. If you cannot say what is OFDM, I started with FDM, then I said what is OFDM, okay? Almost 2-3 slides with clear picture, with block diagram, okay? How it is done and all I said.
So in FDM, we have guard bands. In order to avoid interface between the two bands, so the guard bands have been introduced. Whereas in OFDM, we don't have any guard bands, so it saves the bandwidth of that signal.
Yeah.
And the
Yeah,
principle
very
of
good. At least you're
OFDM is,
opening up your mouth. Yeah. Yeah,
and the
one thing is,
principle of OFDM, yes, sir.
yeah. Yes, come on, continue.
And the principle of OFDM is it divides the spectrum into large number of tightly packed narrow subcarriers. So at the
Okay.
peak of each subcarriers, all other subcarriers will have zero amplitude, which avoids the interface like subcarrier interference,
Yeah, inter-channel interference.
interchannel interference. Yes, sir.
Okay. Yeah. What in? Yeah, it is fine. I think others should talk now. Okay, fine, Akshata. Yes. What about others? Yes, at least Akshata could reproduce our understanding to a certain extent. Yes, others I'm asking. See, out of 35, only one student or two students are able to talk. What other rest 33 students are doing? Yes, Vido, can you just quickly tell what is the OFDM principle with block diagram I said now, OFDM transmitter and receiver? Vido.
Yes, sir.
Yeah, unmute and talk now. Why again you are muting? I asked OFDM principle, right? I told with block diagram, that process. You should be able to catch that, how it is done. See, a high bit rate serial data has been converted into parallel one. Okay, serial to parallel converter. Okay, this is all just, I will refresh. Okay. Yeah, I said what is the difficulty that is with the wireless channel, that is multipath propagation. Due to that, there will be inter-symbol interference. If you want to achieve high data rate, obviously the symbol duration will become very small. So since it takes multiple paths to reach the receiver, okay, if the symbol duration is much smaller than the delay spread, then there will be a inter-symbol interference. So to overcome that problem, we go for OFDM. What is done in OFDM? The high data rate, okay, with the short symbol duration will be passed through serial to parallel converter. By doing so, we will be able to increase the symbol duration. Okay. Then each that parallel bits will be modulated by using different carriers, and then it will be summed up. So that will give you the OFDM signal. Okay. So just I said about this, means how do we do that? This is analog way of doing that, modulation, multiplication, then other things. So now we use the IFFT and FFT. IFFT is used in the transmitter side and FFT is used in the receiver side. Hope you are aware of what is IFFT and what is FFFT. You might have studied very well in the lower semesters. So you should be able to apply that knowledge here. Okay, how IFFT is applied here to process that signal. Okay, digital signal. Fine. So with the use of that, we will be able to get many advantages. So I was talking about those advantages, right? So the first thing is, I said the use of OFDM is it provides an elegant solution to multipath interference. So how does it provides and all I said. Okay. And the second advantage is it reduces the computational complexity. The use of FFT and IFFT in the transceiver, right? So at what rate means what is the reduction in the computational complexity? Also, I expressed it with respect to equations, right? If we use the conventional method of uh, combating the multipath interference, that is what the time domain equalizer, that system has the complexity of O into B square into Tm. Okay, if you use the FFT and IFFT for combating that is the OFDM implementation, right? So with that, the computational complexity has been reduced to O of B into log B into Tm, where B is the bandwidth and Tm is the delay spread. Okay, that computational complexity will be much lesser than the conventional method. So because of the reduction in the complexity, okay, and this is very much attractive in the downlink because it will simplify the receiver processing. So when it simplifies the task of receiver processing, it will be reducing the cost of the mobile and as well as the power consumption of the mobile device. So we all know what is the hungriness of the battery, right? If you are charging every hour, there is no meaning for that, right? At least once we charge, if it is coming for one day, we are very happy, right? So that is the advantage. So third one is third advantage of OFDM, what I'm saying here, okay? So what I can say is there will be graceful degradation of performance under excess delay. Means the performance of this will be slower when compared to any other technique. That's what the meaning of this. Okay, the performance of an OFDM system degrades slowly as the delay spread exceeds the value whatever it is designed for. Okay, I said the delay spread is an important parameter. The value of the delay spread should be much smaller than the duration of the symbol. Then only I can say there will be no inter-symbol interference, right? Even if there is a slight increase in the value of delay spread, the performance of the OFDM will not degrade so quickly. Okay, that is what the meaning is. The next one is greater coding and low constellation sizes. I hope if I say constellation size means it will be applicable for the modulation techniques, right? So with respect to BPSK or FSK, even QPSK or QAM, you should be able to visualize that constellation diagram, that is in phase and quadrature phase, how the signal is represented at each quadrant, right? So low constellation size, it may be for even QPSK when compared to QAM, right? So that can be used to provide the fallback rates that are significantly more robust against delay spread. Means the low constellation size means we can go for QPSK and greater coding techniques when the delay spread is slightly more. Then this adaptive that is OFDM is suited for adaptive modulation, okay, and as well as coding. So we'll discuss in detail about this AMC, we call in short, adaptive modulation and coding. I said this OFDM is suited for AMC, that is adaptive modulation and coding, which will allow the system to make the best of the available channel conditions. This adaptive modulation and coding is a technique which allows the system to make the best of the available channel conditions, okay, with that technique. So under this, we say how the performance of the OFDM, okay, decreases slowly when the delay spread increases to certain extent. So next one is Means this OFDM can exploit the frequency diversity. Okay, so we can talk about different types of diversities, frequency diversity, time diversity, and all. So just I will say here how this OFDM, okay, will be able to exploit the frequency diversity. So it facilitates coding and interleaving across subcarriers in the frequency domain. Okay, so I hope you are aware what is interleaving. Just meaning of interleaving, I hope you are aware. Say if I have numbers 1 to 10, in that 1, 3, 5, 7 is what? What I can say 1, 3, 5, 7.
Odd numbers.
Similarly 2, 4, 6, 8, right? So there is a gap, no, in between, right? In a similar kind of that is known as the interleaving, we say. So we can have interleaving across subcarriers in the frequency domain. So with that, it is possible to provide the robustness against the burst errors. Okay, that will be caused by portions of the transmitted spectrum undergoing deep fades. Means this fading is with respect to channel. Okay, when a signal travels over a channel, depending upon the channel condition, the strength of the signal will reduce. Okay, so how do we because of that there will be some errors, right? How do we overcome that problem? So this can do that. This OFDM can facilitate or exploit frequency diversity by doing that. Okay, and it allows, that is OFDM allows the channel bandwidth to be scalable without impacting the hardware design of the base station and as well as the mobile station. Okay, so bandwidth is scalable. Because of that only we will be able to operate this LTE in a different bandwidths, that is from 1.4 to 20 megahertz. So without changing the hardware design of either of the base station or the mobile station. And yeah, that is what the meaning I said. The last point is that one only. Because of that, it is possible to support different channel bandwidths. Okay. So the next point is it enables efficient multi-access schemes. Okay. So this the use of OFDM, okay, orthogonal frequency division, enables efficient multi-access schemes. So multiple access schemes, as I already told in brief, are what? FDMA, TDMA, then OFDMA, SC-FDMA and all, right? So this OFDMA can be used as a multi-access scheme by partitioning different subcarriers among multiple users, that we call as orthogonal frequency division multiple access. Okay, so which is used in the LTE for downlink operation. And this OFDMA offers the ability to provide fine granularity in channel allocation. So this is also a very important point. Now, just keep in mind the granularity. We are looking for fine granularity. Means granularity is the smallest of smallest thing, right? So while allocating the channel, I think I will be able to explain this in a better way when we are discussing about the subcarrier spacing and how the channels have been allocated for different users and all. So as of now, you can just try to understand this multiple access technique. What is that? FDMA have the ability to provide fine granularity in channel allocation. Okay, so which can be exploited to achieve significant capacity improvements, especially in slow time varying channels. So every word is important here. See, time varying channel, in that again I am talking about slow time varying channels. Similar to that, there will be a fast time varying channel also. Okay, so this OFDM technique is especially useful to improve the capacity of the system significantly in slow time varying channels. Yeah, so the next advantage of this OFDM is it is robust against narrowband interference. Okay, so how do we say that this OFDM is robust against narrowband interference? Is because this narrow interference will affect only a fraction of the subcarriers. Okay, fine. And it is suitable for coherent demodulation. At least you have an idea what is coherent and non-coherent, because we have discussed many coherent detection techniques in the previous semester, that is in digital communication. Any one of you, is it possible to say what is coherent detection? Is it possible to recall coherent? Yes, that's what I require. I need response. Coherent. These are all basic things because semesters we have spent. Okay, and you should be able to say. And even I stressed upon such things. Coherent detections. Most of the things we have discussed about coherent. Yes, quickly, any one of you before I call by specific names.
We use BSc.
Huh?
We used it in DSP. Sir.
Fine, man. What it is? What do you mean by coherent?
Sir, it's like synchronous detection.
Synchronous, right? So synchronous detection means, yes, anyone, any other people can add on to this. What Vishnu is saying. He said yes, it is synchronous detection. Fine. To have a synchronous detection, what should be the same thing at the transmitter side and receiver side? I expect that to say.
Phase. Phase.
Huh? Your voice is breaking, Akshata.
Phase.
Phase the
Yeah, repeat once again. Yes, Navya was saying something. Coherent. Yes, Navya.
signal at the transmitter side should be as the phase of signal receiver side.
Signal condition is very poor. Could not hear anything. I don't know whether my voice is audible, clear.
Yes, sir.
Yeah. Yes, quickly, anyone can say. You were talking about something, phase, frequency and all. With respect to what, it should be same.
Carrier.
Yeah. The frequency of the carrier, the frequency and as well as phase of the carrier, what we use in the transmitter and receiver, right, should be synchronized. Then we say it is a coherent modulation and a coherent detection, right? Yeah. So this OFDM is suitable for coherent demodulation because here we will be using the pilots. Okay. So it is relatively easy to do pilot based channel estimation in OFDM system, which will be suitable for coherent demodulation, okay, that are more power efficient, what we say. So just to understand, here I have given one simple diagram. Okay, so these are all the data sub carriers, what is written. So in between it is mentioned, right? So they're called the pilot sub carriers. So for every few microseconds, this pilot sub carrier will be transmitted, so that it will be checking whether it is synchronized or not. Okay, so with the use of this, even this technique is also power efficient. We can save the power also. So with respect to that, it is what we can say is suitable for coherent demodulation, OFDM technique. So I am explaining this under suitable for coherent demodulation. Okay. Then the next advantage of the use of OFDM is it facilitates the use of MIMO. Okay. So facilitates the use of multiple input, multiple output system. So this MIMO means it is basically a signal processing technique which uses multiple antennas at both the transmitter side and receiver side to improve the system performance. Okay. I will show with the figures how this, at least are you able to grasp this definition? I said MIMO is a what? Collection of signal processing technique that use multiple antennas at both the transmitter and receiver to improve the system performance. And this is effective when the channel conditions are such that the multipath delays do not cause the intersymbol interference. Only in that case, this is effective. Okay, the channel has to be flat fading channel and not a frequency selective. So, okay, as of now, you are not aware what is flat fading and frequency selective. We'll have a discussion on that when in the subsequent classes. Okay, so this OFDM will be converting that frequency selective broadband channel into several narrowband flat fading channels where this MIMO model will be effective. Okay, so the ability to effectively use this MIMO technique is to improve the system capacity. It gives OFDM the significant advantage over any other techniques. Yeah, just to understand what MIMO is, I have kept this slide. Okay, I hope you are able to understand here. See data from each different streams, right? So this is the MIMO transmitter processing. So multiple antennas are used with the transmitter side. Then similarly, the multiple antennas are used at the receiver side. This we call it as a multiple input, multiple output system. I think this much is more than enough as of now, because we need to start with SISO, that is single input, single output, then single input, multiple output, then multiple input, single output, then only this multiple input, multiple output will be able to understand. Okay, so we'll talk about this later on. Just to get an idea what is MIMO, I'm showing with this. I said OFDM facilitates the use of MIMO, right? Yeah. Then I think this will be the last advantage of OFDM. So that is, it supports what efficient support for broadcast services. So this is also an important advantages of OFDM. What it is it will be able to synchronize the base stations, okay, to the timing errors well within the OFDM guard interval. So it is possible to operate an OFDM network as a single frequency network. So SFN, what we say, single frequency network. So I repeat once again, the use of OFDM, okay, with the what? It will be an efficient support of broadcast services, we say. Okay, how does it will be happening that? It is having the ability to synchronize base stations to timing errors within that OFDM guard interval. So it is possible to operate an OFDM network with a single frequency network, we say. So that allows the broadcast signals from different cells, okay, to combine over the air to significantly enhance the received signal power. So thereby it will be enabling higher data rates broadcast transmissions for the given transmit power. That is how we say it is useful. So every line, every word is important here. It is not that easy to grasp what I am saying. So since it is the beginning of the module, right? At the beginning only, you will not be able to get clear understanding about all these concepts. As we proceed further, you will be able to. Okay. So we'll talk about what is a single frequency network in detail when we're discussing about the broadcast services. At least now you should be having some idea. Okay, this is what it can support. The use of OFDM can support broadcast services. How that is achieved? You should have the term in your mind, that is single frequency network. What is a single frequency network? Also, you should be able to say in one line, it is possible to operate the OFDM network as a single frequency network by synchronizing base stations to timing errors. Like that. Okay. So here I said means the use of the single frequency network will be allowing the broadcast signals from different cells to combine over the air to significantly enhance the received signal power. Thereby, it will be enabling higher data rate broadcast transmissions for the given transmit power. So these are all some advantages of OFDM, which has made to choose this OFDM as one of the key enabling technology for the LTE. Okay. So hope you are able to grasp at least in brief what is what. Yes, at least heading of, is it any one of you can summarize the headings? How many points at least noted? Of course, under each heading, I've taken some 2-3 paragraphs for explaining. Okay. Just a quick review. I will come with this. I said, whatever highlighted with red thick line, no, that is what elegant solution to multipath interference. That is one advantage. How it is going to be an elegant solution, I explained that here. Okay. The next is reduced computational complexity. So how it can reduce the computational complexity? So with the use of F50 and IF50 at the transceiver, I said. Then there will be a graceful degradation of performance under excess delay. Okay, how the performance under excess delay is not going to be rising rapidly, how it is going to degrade slowly, I'm telling with respect to this. Then it has the ability to exploit frequency diversity. Then it enables efficient multi-access schemes, I said. Then robust against narrowband interference. Then I said it is suitable for coherent demodulation. Okay. Then I said it facilitates the use of MIMO. Yeah. Then is the last one, that is efficient support of broadcast services. So if you have noted, is it possible to say how many advantages I listed here? That is why I not given the number. If I would have given the number, it would have been told very quickly. Yes, any one of you can say? Yes, Shreyas. Shreyas. Yeah, roughly can you say how many I have listed here? Yes, are you talking? Shreyas.
Yes.
I'm not able to hear, man, your voice. Shreyas.
Yes, sir.
Huh? Yes, talk with little bit loud, na?
I don't know, sir.
You don't know. Means you're not listening what I'm saying. I repeated twice, man. I read the headings once. At least, but then you people are not noting anything. Hmm? Yeah, I understand. See the terms now, you will be hearing first time many things, right? Flat fading channel, frequency selective channel, all key things which we need to understand. Okay. But at least I have given a sufficient justification, I think, how each advantage is achieved. Hmm? Yes, what about Gautam? Gautam is not there only. What about
Yes, sir.
Dharma?
Good morning, sir.
Yeah, Gautam, can you just tell the numbers? I'm asking number. How many advantages I have listed out here?
5 advantages.
5. You noted only 5, I think. I have not. I have listed more than 5, man. Hmm? Okay, you said 5 now. At least can you mention those names?
It supports for the broadcast services, efficient broadcast service, and it enhances
So it is rightly available now.
it enhances a number of users in the means channel dependent number. It increases the number of users in a single channel.
No, man, no. That is a technology. What channel dependent multi-user scheduling is a technology that not comes under OFDM advantage.
So multiple input, multiple output.
It facilitates the use of MIMO.
And
Then only it will give meaning, no? Yeah.
And
But the first one, man, why you are struggling so much? It is, I said, it is an elegant solution for multipath interference. That is, it can overcome inter-symbol interference, ISI, right? Then what else? Reduced computational
Also.
complexity, right? With the use of FFT and IFFT. IFFT is used at the transmitter side, FFT is used at the receiver side. So it can reduce the computational complexity.
It's relatively robust against narrowband interference.
Then suitable for coherent demodulation, right? It exploits frequency diversity. See, it should be there. See, at least if you write these names, I will ask again some other people. People should note down at least these names. Cannot keep quiet. I said first one is elegant solution to multipath interference. Elegant solution to multipath interference. The second one is reduced computational complexity. The second advantage of OFDM, what I can say. Third one I said graceful degradation of performance under excess delay. Okay. The fourth one, that is exploitation of frequency diversity. Okay, exploitation of frequency diversity. So next one is it enables efficient multi-access scheme. Enables efficient multi-access scheme, that is OFDMA. Next is robust against narrowband interference. Then I said it is suitable for coherent demodulation. Then I said it facilitates the use of MIMO. Then efficient support of broadcast services. Okay, so these are all the advantages of OFDM. So don't you think it has any disadvantage? So obviously anything which exists have certain advantages. Obviously it will have certain disadvantages. So these are few disadvantages what we can say with respect to OFDM. So first thing is high peak to average ratio. Okay, peak to average ratio is a PAR we say. Okay, so it causes non-linearities and clipping distortion when passed through an RF amplifier. So by having high peak to average ratio, what is the difficulty? It leads to what? Non-linearities and clipping distortion when that signal is passed through an RF amplifier. So that is one drawback of this OFDM. Means what? Non-linearity. See, amplifier, you all know gain is important and linearity also important. So both cannot be achieved simultaneously. So there will be a trade-off. Okay. So you know where do we get the clipping distortion, right? Hope you all able to visualize the concept of operating point with respect to transistor, again I go back to the basics. Okay, if the operating point is at the center of the load line, then we will be able to reproduce the signal faithfully, right? If the operating point moves towards either to the y-axis or towards the x-axis, what happens? Some portions of the signal will be clipped off. So that is what the thing is happening here. Okay. Hope you're able to visualize that. The concept of operating system, why it should be at the center of the load line, why if it is moving towards y-axis, what happens? If it is moving towards x-axis, what happens? Right? I said what I mean to say is it has to be in the what? Active region, right? If it moves towards saturation or cutoff region, you know the difficulties. The same thing for here. So that is the one disadvantage what I can say. High peak to average ratio causes non-linearities and clipping distortion when it is passed through an RF amplifier. To mitigate this difficulty or problem, it requires the use of expensive and inefficient power amplifiers, okay, with the high requirements of linearity, which will increase the cost of the transmitter and is wasteful of power. Okay, so if at all I want to mitigate this high peak to average ratio, I need to go for what? An power amplifier which is not that much efficient, and it is also expensive. Okay, because I have to have a more linearity. So to achieve more linearity, so that will be with the cost, means which will increase the transmitter cost, and it is also wasteful of power. Okay, so means the concept of OFDM is applicable or can be used at certain places, not at both the user end and as well as other end also. So that is why it is preferred to use in the base station, not in the mobile. Okay, not in the handheld device. Okay, for handheld device, something else. You got my point? Yes. Okay, so the next enabling technology is this one, SC-FDE and SC-FDMA. So what is SC-FDE means? Single carrier frequency domain equalization. Okay, and SC-FDMA is single carrier frequency domain multiple access. Okay, I said no, the OFDM is having the problem of what? High peak to average ratio, right? So to overcome that problem, we need to go for a better power amplifier which can increase the linearity of the amplifier, but it will cost more, right? And it is not power efficient. So to avoid that, we need to look for cutting down the cost, right? And in the meantime, we need to increase the battery life, right? So that means this LTE has incorporated the power efficient transmission scheme for the uplink. So this is especially for uplink. Uplink means what? From your mobile station, that is from your user equipment, or is also known as mobile, okay, mobile station to base station. Okay, so I cannot afford to use OFDM in the mobile. Okay, it can be offered to use in the base station because its capacity is big. We can use a high cost power amplifier there, not in the handheld device. Okay, so which is possible to cut down the cost and increase the battery life by using a technique called single carrier frequency domain equalization, that is SC-FDE. Okay, so in brief I will tell in what way this technology is going to cut down the cost and as well as improve the battery life. We will have a discussion in detail in the subsequent lectures with the block diagram and other things. Okay. So here, in case of single carrier frequency domain equalization, what is happening is the data symbols are sent as a sequence of QAM symbols. Okay. So hope you are able to visualize this. What I am saying, data symbols are sent as a sequence of QAM symbols. So in the same way, you can understand with respect to OFDM also. There also the incoming data, okay, that is serial data, which is having high bit rate, is passed through a serial to parallel converter, right? Then we used to do the modulation, right? So here also in the same way, the data symbols are sent as sequence of QAM symbols with a cyclic prefix is added to that. I will come back to this, what is cyclic prefix and all. Okay, so the IFFT is added at the end of the receiver. So with that, what we can do is we will be able to reduce this peak to average ratio of 4 to 5 dB. Okay, so for this multi-user version of this SC-FDE is known as the SC-FDMA. Okay, so SC-FDE is for single user. If I want to adopt or extend that for multi-user, then we call that as a single carrier frequency division multiple access technique. So which will allow multiple users to use part of the frequency spectrum. And we can think this SC-FDMA as DFT pre-coded OFDMA. So DFT, at least you are aware of name. What is DFT? That is discrete Fourier transform, pre-coded orthogonal frequency division multiple access it is. Okay, so this SC-FDMA, hope you are able to understand now in what way SC-FDMA is different from SC-FDA. SC-FDA is for single user. If I want to extend that for multi-user, then I call that as a SC-FDMA. Okay, so SC-FDMA will preserve the properties of peak to average ratio of SC-FDA, but it will increase the complexity of the transmitter and the receiver. Okay. Just have an idea how this SC-FDMA works. I have kept this picture at this stage. I will give 2 minutes time. Just try to understand how OFDMA and SC-FDMA is explained here. Even not, I think 2 minutes may not be sufficient. At least with attention, focus, I think I can expect some answers from your side. QPSK only is here. It is a single carrier frequency division multiple access. In what way SC-FDMA is different from OFDMA? Hope you able to see this diagram, na? Yes, I'm asking.
Yes, sir.
Hello, is it possible to? Yeah, you want me to put a full slideshow? Yeah, now I kept slideshow. Is it possible to see this single carrier FDMA diagram?
No, sir. We are still in the previous mode of this.
You're still in that mode only. Okay, fine. Okay, of course, still you are not aware what is cyclic prefix and all. May not have that much clear. At least so each symbol of data is represented with different colors. Okay. Hope you understand. One with the red color, then 01 with the yellow, right? Then 00 with another color, then 1 0 with another color, blue color, right? So that is what the different symbol. And here the carrier spacing is of 15 kilohertz, right? So data symbols will be occupying 15 kilohertz for one OFDMA symbol period here in case of this. Okay. Then here the data symbols will occupy what n into 15 kilohertz for 1 by n SC-FDMA symbol period. So here the value of n will be 4. In that sense, it is taking 60 kilohertz. Okay, that is 4 symbols, right? 1, 2, 3, 4. So 4 symbols. That is why I said here 60 kilohertz. Okay. Yes. Yeah, I will come back to this when we're discussing with block diagram. Then you need to have still some more understanding about the clear picture of subcarrier spacing and other things with respect to OFDM. Then I think at least now this diagram will make you to get some idea how SC-FDMA is different from OFDMA. So with respect to this OFDMA symbol, just think, right? And here this SC-FDMA symbol. See, each symbol is for different user, right? So how many users? That is why we call multi-user. Yes, what do people can interpret this based on looking at this diagram? Anyone has any thought process about this? Looking at this diagram. Yes, someone is talking something. Yeah, Aman Sharma.
Sir, in OFDMA, according to the diagram, it appears to be like for different users, there are different set of frequencies. But in SC-FDMA, there is a single set of frequency given to different users at different time intervals. So there is better usage of frequency in SC-FDMA.
Very good interpretation. Yeah, very good, Venkatesh. Keshav, your name is Keshav, right? Yeah.
Yes, sir, Keshav Venkatesh.
Yeah, thank you, man. Thank you. At least you could observe that. Yeah. Yes, similar to that, anybody, any other student can interpret. Hope you people have understood now what he has interpreted. Yes? Yes, Sudarshan. Sudarshan, Dharma. Yes, Deepak Tiwari. Yes, Deepak Tiwari. Not there only, simply joined. Chandan?
Yes, sir.
What is your understanding, man? I shared the slide. Keshav Venkatesh has interpreted his understanding about OFDM and SC-FDMA. What is your understanding? Are you able to see the slide of what I've shared, SC-FDMA and OFDMA?
Sir, in SC-FDMA, we are using single frequency for most purpose, but in OFDMA, we are using multiple frequencies.
Okay. Then, what about Chandan? What is your understanding, man? Chandan?
Same, sir. I also observed same. Like
Yes, Chandan. Chandan, you can't talk? ಏನು ಮಾತಾಡ್ತೀಯೋ ಮ್ಯೂಟ್ ಮಾಡ್ತೀಯೋ ಒಂದು ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ. Yes, what about Saujanya?
Yes, sir.
Yeah, can you interpret your understanding about OFDM and SC-FDMA looking at the diagram?
Sir, I could also tell the same thing as what Deepak told, sir, regarding the
No,
common.
you can repeat. You don't have to say what Deepak told. You can interpret in your way. Same
About
thing maybe you express. I expect you to express your understanding.
the common frequency, which is like a single frequency which is used in SC-FDMA, but when it is OFDMA, there are different, I mean, multiple it is used, not a single one.
Okay. So here the bandwidth allocated in case of SC-FDMA, it is of 60 kilohertz, right? So that 60 kilohertz is fixed for every user, right? Same amount of bandwidth will be using, but at different intervals of time, right? So in time axis, different colors are there, means is a different data, right? That is with respect to SC-FDMA one symbol. Here, in case of OFDMA, each user will be using a frequency of 15 kilohertz as its bandwidth over the entire one OFDMA symbol, right? In time axis, it is common, right? But with respect to frequency axis, they are with a spacing of 15 kilohertz each. Okay. Yes, is that fine? Okay, with this, I will stop my today's class. So all of you write your revisions in the chat. Yes, hope everybody has written your revision in the chat box. Shall I close?